Okay, welcome to MathPro, where we teach link thinking, boldness, and perseverance in problem solving. All right, so this is today's puzzle. This is today's puzzle. All right, math is just like puzzles. Okay, so we have this equation here, right? You have left hand side, right hand side. It's true for all values of x not equal to 2 over a, where a is a constant. What is the value of a? Okay, that's today's puzzle. Okay, with a lot of practice, it's really quick. But this is how you're going to solve. Since we have only one variable a here, it's really easy. But this is how, just in case you have two variables, this is how you're going to go through. So let me give you the link exercises. Okay, so the first fact I give you here is if 64 divided by 5 is equal to 12, quotient is 12, remainder 4 over 5, then 5 times 12 plus 4, right? The divisor times the quotient plus the remainder. It gives you the dividend. Okay, so the first question I have here for you is, which of the following expressions is equivalent to this one here, right? Okay, all right. What will be your answer? What will be your answer? Okay, all right. So what do? If you have x plus 2 minus 4 over 3, okay, if you're looking at the answers, you see everything is being combined. So you need to combine these two. Okay, so you can use, if you have 3 minus 1 over 4, what do? You can say 3, 4 times 3, 4 times 3 minus 1 all over 4, right? You can do that. So we take this, we multiply by this, subtract the 4, everything, then over that. So we do that, and then we distribute. Okay, so how do we do that? X times x squared, x times x times 3, and then you come, okay, and then you take 2 times x squared, 2 times x, 2 times 3. So we do that, and then we combine like terms. So you're going to get x cubed, and then we have 3x squared plus 5x plus 2 all over, don't forget that part, all over x squared plus x plus 3. All right, and so your answer is C. That's the correct answer. So you know how to combine polynomials, right? Okay, or you can use the LCM, right? You could have said x plus 2 over 1 minus 4 over this, and then you say you want to have the same denominator. So here you multiply the top and bottom by x squared plus x plus 3, right? You do that. Once they have the same denominator, then you can combine the numerator all over the denominator. Correct? Cool? So you got that. Okay, now what about this? Okay, so pay attention. You can go back and review it. Make sure you get the same answer. Now, what about if I have something like this? 6x squared plus 7x minus 3 is given, is you're told is equal to ax plus 3, okay, parenthesis bx minus 1. This is a b, not a 6. What is the value of b over a? So you need to know b and a before you can answer, right? So, okay, so watch, organize your work, right? See how my equal sign is almost lined up. So first thing, rewrite the question. This is identity. You have left hand side and you have right hand side. Okay, so you need to make them look about the same. So what are we going to do? We are going to FOIL, right? You're going to FOIL it. So we do that, and then we end up with abx squared minus ax plus 3bx minus 3. And I'm going to rewrite this part here. Okay, and it becomes, I write it positive first. So 3bx minus ax minus 3. What do I do next? Okay, I'm going to factor this x here, there's x here. So I'm going to factor my x out. When I do that, I get 3b minus a left 3. So now I have identity. What do? I compare like terms on both left hand side. So I say this is equivalent to that. That means AB, this part here, AB equals 6. This is a 6, not a B. AB equals 6, right? What does that mean? A could be 3, right? And B could be 2, or A could be 2, B could be, we don't know. Or we can even have A equals 1 and B equals 6. all sort of combinations. So, but which one works? Okay, you look at it. The one that works is when b equals 3 and a equals 2. So I put 3 because, sorry about that. So first identity is this one. Second identity is the x term. You see the x term is the, you say that the 3b minus a is equal to the 7, right? So we have two equations, okay? So here we have all sort of combination for a and b, but we have to test it over here. So we come and test it. The only one that works is when b equals 3 and a equals 2. So that's our answer. B equals 2, b equals 3, a equals 2. So the question is, what is b over a? B over a is 3 over 2, or 1.5, or 1.5. That's your answer. Okay, so now what have we done, right? Okay, you know that if you have 64 over 5 equals 12 plus 4 over 5, then this part here equals to 5 times 12 plus 4, right? Okay, and you know now how to combine polynomials, right? X squared plus x plus 3. You know how to put this together from 1, okay? What else do you know? You know, okay, when you have an identity, right, you know how to make them look alike. You know how to make them look alike right here. And then compare like terms and find your variables. Now, I say, link it, recall previous skills, the one what we just did. Be bold and logical, persevere, don't quit. Let's go back to the puzzle. Here it is. Okay, with experience, it's really quick. I can tell you that a equals -3. Okay, but what's the thought process? What's the thought process? If you have something like this, remember 64 over 5? 64 over 5, that's your 12, 4, 5. What do? It's the same as, right? It's the same as, what do I do? Okay, this times this minus that all over. Okay, that's what I did. Okay, so now we have both of them have the same denominator, right? So you say this, okay, and that are equal. This and that, the numerators are the same. So I write the numerators to the same. What do? I FOIL, combine like terms, compare like terms, right? And then I find my unknown. Cool? All right. Keep on practicing. What do I say? All things being equal, you shall what? You shall bloom.